Okie dokie. I have a problem here with, well, it's not really a problem, it's so much as asking us to interpret a graph. Let's see. What is one piece of information? Hold on one second here. Anyways, so it's about Allie and her family, and Allie's going on a bike ride, and here's Allie. Right, this is her bike ride right here, and here's her family in the car. And if they go here, let me see if I can scooch this down so we can. Yeah. Okay. We're supposed to answer some questions about where they are at particular times, how fast they're going, and so on. So a couple of things to remember. Notice here that the graph is going up by 10 miles at a time, and hours appear to be going up by 1 hour at a time. So we're told the family leaves at some point right here, and they catch up with her after 1.2 hours. So the amount of time that passes between here when they leave and here when they catch up with her is 1.2 hours. So from those two time zones, so if I follow this straight down, we're 1.2 hours ahead of where they started. Let's see. It talks about Allie pedaling at two different rates. So think about how does a rate look on our graph. Remember, a rate is distance versus time. Okay. And rate is reflected in the slope of the line here. Also, think about, let's see, it says after biking for a while, she stopped to take a rest. How far was she and how long did she rest for? Think about what a rest means. She's not moving, but time is always passing by. So there must be some place where you see that time is increasing, but distance is not increasing. Also, let's see, how far is she from home when the family catches up with her? So when the family, so how far is she from home when they cross paths right here? And let's see. At what time would Allie have arrived if left a bicycle all the way? You kind of see this sort of dotted line here. This is where she would have gone if she had just been bicycling and hadn't been picked up by the family, because the family picks her up in the car here and they put the bike in the back. Let's see. And what distance separated Allie and the rest of the family at 5 p.m.? So you can see, like, here's 6 o'clock, so 5 o'clock is right here. So kind of how far apart are they? Remember, anytime you're asked about distance, right, distance, you're looking at this axis right here and how far apart points are vertically on the graph. And anytime you're asked about time, you're looking at things that are how far apart are they horizontally on the graph. Don't fall into the trap where you think that, this is her actual path and then the family's path is right here, because that would look like, the family starts here and she starts here, but they actually start from the same location. The reason why their graph starts here is because they started later in time. Okay, keep that in mind. So when things are separated on the x-axis, they're separated because they're happening at different times. Right? This happens much later than this event over here. When things are separated on the y-axis, they're happening at different distances from each other. Okay? All right. So I think you can answer these questions, and we'll talk about them in class.